Hello, welcome back to this channel. Welcome back to your community. So today we'll be doing another AI/ML project. It's it's a very beginner-friendly AI/ML project. So hopefully you will learn a lot and enjoy it. Let's go. So first, you can open any browser, Google, Chrome, Firefox, anything. We'll go ahead and type in Google Colab. So this is similar to Jupyter Notebook, but for this specific project, we'll go ahead and use this. So once you click on it, you should be able to get something like this, and you can go ahead and click on New Notebook, and it should give you like a page similar to Jupyter Notebook if you've used it. So what we are gonna do is so the important step here would be to go ahead and download our data set. So before I dive into coding and everything, so this project specifically would be about the IRIS flower classification. So first of all, we need to go ahead and get and download the data set. So we just type in IRIS flower dataset. So if you go here, so here we'll just go ahead and since I have it already downloaded, I'm not gonna download it again. So you can go ahead and download it, and once you have it downloaded, then we can go ahead and import that file into our Google Colab ML project. So how can you import it? By going, so first you'd be here, by going to here, and then click on this file button, and then you can choose the IRIS dataset, which I have it already downloaded. So as we see, it's getting downloaded. So once we have our data set, we can go ahead and start coding. So we wouldn't have to code a lot. So this is just a beginner project, but it tends to build a lot of knowledge. So in this project, we'll be using three types of um, algorithms, which first one would be the decision trees algorithm. Second would be the logistic regression algorithm. Third one would be the vector machine algorithm. So we'll go ahead and start coding. So first we will start by importing some libraries. Libraries that we need to import would be pandas, and another one would be seaborn for the visualization, and another one would be numpy for the data sets, and another one would be the matplotlib.pyplot, if I'm not wrong, yes. So we'll go ahead and matplotlib inline. So let's see if we get any errors. So so that should be okay. So now that we have imported all the things that we need, we can go ahead and create another cell, and here we need to extract the data from our from the IRIS data set, like from the IRIS file that we downloaded. So how are we gonna do that? So first of all, we're gonna make a variable. You can call it df equals to. So for that, we're gonna use panda. So pd dot read csv, because that's the extension of the file, and first parameter that's gonna take is gonna be the file name, which is iris.csv, and the second parameter is gonna take. So one thing that I forgot to mention, as you can see here, we have every column has a title. So what we need to do is we need to say column equal to a list of we could just. So what I just did was I copied all the title of the columns and I pasted them here. So what now we need a variable to assign it to the columns. So now what we need to do, we need to, so now we want to turn all the values from the columns to a numeric value. How we can do that? By a simple for loop. Once we have done that, we're gonna. So I also forgot to mention. So I will post all the code in the comment section or in the description of this video, so you can also, if you're stuck, you can also use the code to debug or understand better. So pd to numeric, because we want to so that should and we also need to assign the errors to. So hopefully we're not gonna get any errors. So we didn't get any errors. So our data set's been initialized correctly. So now we need to go ahead and make a new cell, and here what we can do, we can do df.describe. So if we print this, we should be able to get, so we should be able to get our the mean value and the error, and most, which is these values are really important for data science. So now we'll go and create a new cell. So here what are we gonna do? So I'd like to show you guys a really cool feature of Seaborn, and we're gonna copy these two libraries because I don't want to run into issues, so just making sure, but I know they're imported. So what are we gonna do? We're gonna use the Seaborn to visualize data. Sn dot we're gonna use the pairplot df, and here, oh, actually we don't need a variable for this, just call it so, and that is gonna be equal to class labels, labels and the pyplot library to show it. So if hopefully we don't run into any issues, we will be able to go. Yes, so here in this this is a really good visualization, and it's really helpful to understand. For example, we could see that the IRIS.csv sepal length has the greatest sepal length, and then for others you can also kind of see for yourself. So for right now we're gonna move on, and we're gonna go ahead and make a new cell. We're gonna initialize our data sets for training. So we're gonna do data equals to df.values and x equals to data, and we're gonna do comma 04 because remember that we don't want so as I showed, maybe I'll be able to show it to you guys after I print x. So hang on. So the reason why we are only setting x to 4 columns, because we don't want we only need 4 columns, and the last column we're gonna assign y, because that's kind of basically like our results. So and then we're gonna do that comma 4, so that should be that, and then if we do print x, we should be able to so there's no parameters. Yeah, so so as we can see, our data set so they're like, they have like 5 columns, but we don't need the 5th column because that's just the results of we only need the x. So right now now that we have our variables, we're gonna go ahead and train these. So for training my data, I'm gonna go ahead and create a new cell. So right now we're gonna go ahead and import the scikit library. So if an easy step would be at the scikit own library's website and go ahead and copy the code and paste it, and that would make it much easier. So it was just sklearn modules import train test split. So if I also have it copied, so I'll just go ahead and split and print it, and it will give you the code. Basically so it's just a oh, we should have but you'll have to make your own variables and testing variables and so we're gonna call the train test split, and then we're gonna give it x and y because that's our data set, and then yeah, test size. Oops. Test size. So test size is very important. You're gonna tell it how, on what percentage of the data it should run your tests. So we're gonna see this in a matter of seconds, and it's gonna make sense. So let's run it again. So the code works. So we have so we have our x train, y train, and everything. Now we're gonna go ahead and create a new vector machine algorithm. So we're gonna do import sklearn. So now we can go ahead and initialize a variable to svm, and then do fit. Fit is what that's gonna train the fit. And also there was one more variable, not test train. So let's run it. What else? Oh, it should be svc, not svm. Okay, that's good. So run and do predict function and pass an x test, because that's the data set that we want to test. And we also want to import score accuracy, to be able to see this algorithm. Import accuracy score. So now we can do score accuracy score, and here we can pass in we should initialize a variable here, prd, which is prediction, and here we're gonna pass in our y test, which is the result, y test or y train, I'm not sure, but times 100, because we want the percentage in and we should be able to, so this should be dot I think this should be y test, yeah. So now, okay, so the accuracy score of this algorithm is 88%. So right now we'll go ahead and create test the same data, much more algorithms, and see what their accuracy score is. So we'll just so right now we'll go ahead and we'll do model lr equals train, and this should be it for this. And then we gonna print this, so we need a score equals to so we got a 95%, which is much higher than logistics regression. There we go. And we're gonna do the same thing that we did for the previous models. Score 3 equals to y test, and per 3 100. Print it. So 94. So we'll see that we saw that the logistic, if I'm not wrong, yeah, that had is very important for I guess as a conclusion or the result of this model. So if you want a detailed result, what we can do, there's a library, yes, so it's called classification report, and so what we can do, we can call directly classification report of y test, which is the result. And so now we have 3 models, we have 3 variables that is equal to the model. We can, if we want a specific result, or if we want to dive deep into a model and look at their result, then we can call that model here. For example, let's say that the logistics regression model had a really good result, so we want to look at the report of that result. So we'll just go ahead and call that and run it, and then we should be able to see a more detailed answer. And so with that being said, we're coming to the end of the video, and thanks so much for watching. I hope that it was helpful and you learned something, and if you're doing similar projects. And thanks so much for watching, and I'll see you in the next video. Ciao.